to go in details on arguments related to the data ingestion processes. So the first one is how to upload a set of data set of point of interest using IoT applications. So here is the flow related to all the ingestion modalities, different modalities of the data. So starting from the dataset analysis, you can establish if you have static or dynamic data. The data can be only static, for example, in this case, in the case of the point of interest, or can also be static and dynamic. So we are going to see this first case that is related to the point of interest. And in this case, we have a set of static descriptions, so a set of metadata, and it is possible to make an ingestion that can be regularized and standard. So you can go to take a sort of template in order to regularize your data and use an IoT application that has been also already created by us, and then you can make the registration of the data into our knowledge base without spending so many time. And in the knowledge base, we have already registered some information related to the graph, so coming from the OpenStreetMap, so are related to the road graph setup, so that your point of interest can be connected to the road graph. Okay, this is the view related to the IoT applications. This view is accessible if you register, so if you made the login. So if you enter in the Snap4City platform with your username and login, you can also go to search IoT applications, and you can also obviously create a new one, or when you already have some of them, you can search with a filter and so on. Here is a view of what is a IoT application. So the IoT application are realized thanks to the presence of Node-RED. So our application realized with flows. In the left side, you can see all the blocks that you can use. Each of these blocks, some of the blocks are Node-RED standard blocks, other blocks have been created by us and are connected to the Snap4City services to allow you a set of fast services to connect the data with the Snap4City dashboards and other tools internal of the Snap4City platform. Here is the structure related to the IoT application development. So we are going to see a set of microservices collections. You can go into the platform and search for the microservices. You can search for your IoT application as we have already seen. You can create and modify your application, your IoT application, thanks to the presence of the editor. With this IoT application, you can also realize a set of dashboards or a set of services that can be available on mobile application. And you can also share all the applications that you have done thanks to a presence of a set of services for co-working, such as the resource managers, and you can also search for all the data that you have registered, that you have sent into the knowledge base of the Snap4City. And another services that can be useful to search what you have ingested and inserted into the knowledge base is the service map. That is a tool using a map on which you can search for example, for your point of interests. So here is the details. Here are the details related to the static data ingestion. Here is the flow that you have to do in order to create your point of interest and insert the point of interest in the map, for example, or in the knowledge base. These aspects, as I have already seen, and as I have already said, is in charge of us. So we have already created the road graph, taking it from the OpenStreetMap or from your municipalities, so that you can connect the point of interest to the map and to the road graph. So what are the pre-requirements in order to create and to load the data into the knowledge base? Obviously, when we talk about the knowledge base, we talk about the triples generation, because the knowledge base is written in RDF. Also, so these procedures will allow you to create a set of triples that will be used to register the data into the knowledge base. So the pre-requirements for you, this is not a so technical feature, but you have to know what are the main categories of the CKAN4City ontology. And in order to do this, you can use the service map tool. So you can log in, but also it is not strictly necessary. You can go to the knowledge and maps and search for the service map. Then on the right, you will find a set of tab, regular services and transversal services, and a set of voices. These are the voices, the classes of the CKAN4City ontology on which the knowledge base, the Snap4City knowledge base is based, and that are useful for you to classify the point of interest. So the point of interest that you see in the map have been classified taking into account the CKAN4City multi-ontology. So what you have to do in order to register this point of interest? You have to regularize your data, putting them into a CSV file. So here, as you can see, there are some links on which you can go in details. Thanks to them, you can go in details. So the first step is create a CSV. You can then create your IoT application starting from a sample that is already available. The sample is described here, and you can copy the source code and import the code into your new IoT application. Then you can upload the CSV that you have already created and start the IoT app and register. So close the registration on the knowledge base. So we can see all the phases. So the first one is the regularization phase, and you can create your CSV. This is the raw view, but you can also use, for example, something that could be tabular, but you have to check that the format is this one. And what you have to check? You have to check to fill all the 33 columns in the header, and in the references you can find some samples. Some of the columns can be lived without data, while the other ones are mandatory. So the mandatory fields that have to be filled are the subcategory, so the one that I have already described and related to the CKAN4City ontology, latitude and longitude, because the point of interest have to be put into the map, so the geolocalization is fundamental, and so these three, and also the ID is recommended because if the ID is not present, an ID is automatically created starting from the file name. So you have to know that if you do not put information related to the ID, we will realize the ID for you starting from the information we have, so from the file name. So the other fields are many, so here you can find the most important, so related to the province, the name that can be, for example, in 2 languages, or you can put the information related to the city, postal code, street address, civic number, and short description, and a set of rules, and so on. So here you can see that now we have talked about the column, so this one, that are 33, and you have to fill the row with your data. So the museum, the theater, and hotel. You can also create a set of files that are thematic, so one file for all the museum, one file for all the hotel, and so on. Okay, now once you have created the CSV, so you have your data in a file, you can create the IoT application, and you can make a login and go to the IoT application creation, so here, and you can wait some minutes because it takes some minutes to create a new IoT application. You can copy the source code that is already available here, and you can go and import the code you have copied and click on the button import. Now you have to remind that you have to click on the deploy to save what you have done. And now you have created your first IoT application. Obviously, you have to make some, you have to edit your IoT application. So the first one thing that you have to do is to go here, click on the simple block, and find your ID. So, for example, the ID is an R8 and so on. You have also to modify another block that is related to the email block. So you have to put your credential here, so your password and so on. And then you have to go to the page that is composed in this way, HTTP, IoT, and so on, and put here your ID. Now you can upload the CSV file. So the page is this one. Here you find a form. In the form you can upload the file. So you can choose the file and upload it. Now what appear? The triples. So these are the information that are going to the knowledge base, and you can send to us these triples, or send to us the file you receive in your email, and we will do it for you. We will put the point of interest into the semantic reasoner, so that, for example, then you can see them into the service map tool. So The other argument is related on how to load triples into the knowledge base, but this is features that is only for administrators and on-premise. So the pre-requirements are different, so it is available only for your IoT application and on-premise, so fully and only for administrators. So this procedure is similar to that we have already seen. So we can start from what we have done related to the register static data, so the point of interest on Snap4City knowledge base, but we have to add something else. So how to load static data on Snap4City knowledge base? We have to register static data on Snap4City knowledge base, so the point 1 and 2. So you have again to regularize your data and to create your IoT application. So the application is the same that we have seen before, but you have to connect this block. So you have to put this connection in order to add these functionalities. And remember to deploy it. Now you can upload your file, and the triples will be loaded into the knowledge base. So another modality to load the data is this one, the one that you can see in this slide, and also this one is only allowed to people that has an on-premise Snap4City version, and only for administrators. So in some cases you can have some information that can be together static and dynamic. For example, if you have a cultural event every day you have a new geolocalization point, so new information related to static data, but also dynamic, because every day is changing. Every day an event is made in a different location. So you have to produce a new triples every day. So this is a procedure that is more technical, so that we don't go in details, but you have to know that it's possible to do this. So also in this case you have a predefined IoT application that is available here. The procedure is the same. You can go here in the link, you can copy it, you can import the code from your new IoT app. Here you can see the block that will be available for you is this one, so triples to Virtuoso, and you have to add this other block, the inject block, so the starting one. You have to create a function block and use the debug block that will send messages into the debug tab. And the function block, that is this one, must contain something like this. And in this way, if you start the flow, you can see the triples. So the triples will be sent to us and loaded into the knowledge base. So another argument is related to the data ingestion with the IoT brokers. So here you can see the Snap4City architecture and the data ingestion. So in this case, as you can see, we have a set of different IoT brokers that can be available on the Snap4City platform in order to cover different approaches and protocols. So every new sensor is registered into the IoT directory and into the Snap4City knowledge base, also thanks to the presence of many tools, something like NIFI and Elasticsearch. When the registration is done, it is possible to create a set of IoT applications, so similar to what we have already seen, that can send data connected to the IoT device that you have registered and so on. And also a set of services to retrieve the data are available. So here is the flow related to the static and to the data that has both static and dynamic data. So for example, if you think about the traffic sensor, air quality sensor, weather sensor and so on, you can understand that you have something that is static, for example, the position or the kind of data that each sensor is going to register and so on, while the other data are real-time or periodical data. The real measures every day, the measure will change. So a first part has to be made in order to make the registration of the sensor, and another part has to be developed in order to register the data every day. So the first part is related to the registration of the static data on a sensor, for example. So you have to describe your sensor, to register it on the IoT directory. So now you have an identifier for your device on the knowledge base also, and these identifiers can then use it to create an IoT application and send data on the knowledge base, and also real-time data on NIFI and on Elasticsearch. So here are some references related to the IoT networks concept. So you can see the course 2020 part 2. Related to the IoT registration, you can see, if not performed, the course 2020 part 2 again. And here is the device registration on IoT Directory. So it is possible to make three different kind of registration modalities on the IoT Directory. So you can register a single device at a time. You can make a registration in bulk, so you can register a set of devices with similar features altogether. And the IoT directory, a node, in any case will perform the registration on knowledge base and storage, and storage for data shard. Relating to the IoT directory, here is the flow on which that show us the relation with the IoT registration and the IoT brokers and the services offered to the final users and also to the network managers. So what a network manager can do? He can register new IoT devices on the platform, and also taking information from the broker and also on the knowledge base. He can look at the devices into the IoT directory and also look for the information related to the brokers. You can also search for information on a set of tools, for example, the service map that is strictly connected with the knowledge base. And you can also, so other actions are available for the final users, and obviously also to the network manager too. And for example, a final user manager can register his or her personal IoT device and look at its personal devices on a set of view to search for information related to the devices he created. He can then use the devices into the IoT application in order to send data to them, and also use a set of dashboards in order to search for the data for the devices he created, and also to put this kind of data in a set of dashboards, data and so on. So what are the main features of the IoT directories? So here you can see the registration. So the IoT directory registers a set of IoT brokers, a set of different IoT brokers in order to manage different modalities, different procedures, and obviously also different as to manage different authentications and modalities and different protocols. The registered IoT Orion broker can be queried for collecting their managed devices so that those IoT devices are registered. The directory can also register IoT devices in many different modalities, so mainly singularly or in group. So we can talk about the in-bulk registration. And the bulk registration can be customized based on the creation of a device model to which all the devices registered in bulk have to be compliant. The IoT Edge are registered as special IoT devices. And then the registered IoT devices are saved also into local database and knowledge base. The IoT Directory provides support for security aspects, so it is that are fundamental also to follow the GDPR, and it is possible the generation of certificates, keys and so on, and the collection of keys into the platform when the devices are on some IoT gateway or second level IoT broker. The IoT Directory also manages ownership and delegation modalities for both for the brokers, for the devices, and also for the device values. Here you can find the set of entities that are managed, so the sensor, the devices, the device model, and the IoT brokers. All these entities are managed into the Snap4City platform, and in the column what you can find the actions that are available for each entity. And also in the table you can find by using what kind of tools and what is the role you need to do the actions described in the table. So for example, the IoT sensor and actuator have a set of possible actions. For example, you can browse and use them, you can delegate and discover them, and so on. And all by using a set of several tools to browse the IoT directory, to delegate the sensor and actuators, and the knowledge base, API, and a set of microservices in order to discover, to search the IoT sensor and actuator that you have put into the knowledge base, for example. And all these actions are available for the four kind of different user roles. So we have the manager, the area manager, and tool and root admin. So the manager is the most simple, with a few set of permission, and the root admin have all the permission. And also the tool admin have many permissions. Then we have the IoT devices that can also for them we can browse and change, deleted for all, with a set of tools for all the roles. And only the root admin and tool admin can make the in bulk addiction. So only them can load a set of devices altogether, while the other user can create one IoT device at a time. Also, the delegation and discovery actions are available for all the users. Then only the device model can only be created by the area manager and tool admin, and while it can be used also from all the different kind of user roles. And the IoT broker, finally, can be used by all the people, but can be added, delegated and managed only by the tool admin or root admin tool. So how it is possible to make the IoT broker registration? Here you can access, as now in this case you can see you are, if you are a root admin tool or a tool admin, you can create a new IoT broker, as we have said before. So if you don't see some action, you can ask for a different kind of user role according to your possibility. And in this case, it is possible to create a new IoT broker, and also obviously to see the list of the IoT brokers that are available now in the platform. So you have to go into the IoT Directory and devices and search for the IoT brokers. So here you can look the list of the brokers and also the details related to each broker. In order to add the broker, you have to click into the new IoT broker button, and a pop-up will be available for you in order to specify all the details related to the broker. So the basic information, so the name, the IP, the port and so on. The context broker name is mandatory, so some of the information are mandatory, some other no. And the geolocalization obviously is mandatory, and also the security information. So once you have registered the brokers, it is possible also obviously to make the IoT device registration. In this case, so you can, as we have said, we can register the IoT devices only one at a time or in bulk. So the first modality is available for all the different kind of user roles and is related to the registration for one device. So in this case, for example, you have a new device is acquired and you want to register the device into the platform. So you have to buy your device, your sensor, and register it. For example, you can register many different kind of devices, Sigfox and GSI and so on, so Power and so on. You can attach them by models, and each different device will work with a range of protocol, formats, approaches and so on. So you can create your own devices with some different technologies that are available in the platform. And how you can do it? You can obviously make the login, go on My IoT Devices, click on the button Add New Devices, and look at what kind of data you have to add. Obviously, so you have to add some general data related to the name, to the model, to the position, so that you can see also the position in the map, and you have to put also the key that are relevant for the security. Okay, and here are some action that you can do into the devices, so so that you can see so we have already seen this one. Okay, so you can see the list of the devices. If you have the permission, you can also edit them or modify them or delete it. You can see, you can search them and see them also in a map, and so on. So you can see that are present two main views. That one is the IoT devices and the other is the IoT sensors and actuators. So how is possible to discover an IoT on an IoT device in an IoT application? So in this case, you can open an IoT application and you can use the device-based search module. In this way, you can use a set of features to use some functionalities that are available for you. So that you can register and search a set of devices directly from a node-RED flow. So other activities related to the IoT data ingestion are the registration of an IoT devices, or as we have said, a registration of a set of IoT devices with loading them in bulk. So the registration implies the production of a model into the knowledge base. And this automatically implies again the activation of a data shadow memory for historical data access, the activation of discovery mechanism, and the activation of dashboard wizard. So what is the meaning of a model? How can I register many IoT devices? So the first step is to register a model and then make a set of make the relation among the IoT devices and the model. So the pre-requirements in order to do this action is to be tool admin user. And if you have, when you do this, if you have a set of sensors with the same features, so if you have 100 sensors having the same features, you can establish what are the features, so the static features, the static data, the static metadata, and using the model, and then you can use the description you have done in order to connect to instantiate the devices. And the instances, so the devices, have to be compliant with the model you create. This is not time consuming and avoids errors. In this case, you are safe that all the IoT devices you connect into Snap4City have the same features. Where you have to go? You have to go into the menu, IoT Directory and Devices, IoT Device Models. You have to click on the New Model button. And these are the pop-up. The main pop-up is this one. So that this is a sample related to the charging station model, so that can be useful to see something that has been already filled in. So in the first pop-up, you can fill it with the general information, so the name of the model, charging station model for example. You can also add a set of description in your language. You can add the device type, charging station, and some of the information are mandatory, some not. For example, the frequency is related to the real time or the periodical data. So you have to know how is the periodical frequency of the update of your data. So every 10 minutes you can put 600 seconds and so on. So the charging station model you have to add also the information related to the IoT broker, because you have to connect the devices to the broker. So here there is a set of brokers that you can choose, and you can select the broker to which your model and your devices will be connected. Then there is the last one tab on which you can put the information related to the value. So you had to click on the add value, because at first when you create the model is void, this view, and you have to put on the add value. This is mandatory, so you have to put the date observed field with these features, the features that you can see, and the other one are related to your device. For example, in the case of a charging station, we have a charging state value, a station state value that are integer, and so on. Then you can choose the data type, the value unit, selecting them from a multiple choice, a one choice, it's not a multiple. You can select only one choice, but you are guided in this thanks to the user interface. So once you have created the model, what you have to do, because you have to upload the data, the IoT devices in bulk. So again, you have to create a CSV. So a file containing all the data related to the charging station in this case, in the case of the charging station model, but are related to the device. So here is a sample of the file, is in a tabular modality view. The fields contained into the column are related, as you can see, to the field of the model. So all the information that has taken into account to produce the IoT model have to be put also into the file. Obviously, we have an already available file that you can download and with which you can start to fill. So the columns are already present and the rows are void. You have to insert data into the rows. Each row is one IoT device. Another things to say is that the key, in this case, while in the model or when you create one device at a time, can be created by the platform. In this case, you have to create the keywords. And here are the details related to the keywords creation. And the keywords can be the same for a same set of devices. So one model, one, key 2. Key 1 and key 2 are different, but the set of them can be the same for all the devices. This because then you can recognize the devices in group thanks to these two keys. and is related to the security aspects, obviously. So if you go to the IoT Directory and Devices, IoT Devices Bulk Registration, once you have the CSV file, you can upload it. So you have to select the model here. In this case, we have the charging station model. Then you have obviously to select the IoT broker that has to be the same that you have put into the device model. And then you can upload your CSV file. And then you can click on the upload, and you will receive a response here. And also here you have the status. So here you can see what are the results of your upload. We hope that all the results will be valid. In this case, if they are valid, you can upload them into the IoT directory. After the upload, you can verify the presence of your devices into the IoT directory, and you can go following the menu IoT Directory and Devices and IoT Devices, and you can see the list of the devices, and obviously you can use the search field in order to find your new IoT devices. Also in this case, you can find additional information in this URL. And now we are going to talk on the real-time data ingestion via IoT applications. So you can go in details and see the main architecture, so is related to these features, so data ingestion and IoT. So the flow is related to the data having both the static data and real-time or periodically data. So the static data are, so this kind of data are typically sensors, so the sensors are registered in the brokers, so we have already seen how to do it. And then we have to connect the real-time, or we can say the dynamic data to them, to the IoT devices that we have already registered. So we can create a set of IoT application. The modality is that can be managed is also in push or in pull, and the real-time data are connected to the IoT devices that have been already registered on the IoT directory and also on the knowledge base. It is this one, and we go to make a subscription node to index all the data and aggregate them thanks to the presence of NIFI and Elasticsearch for the dynamic data. So what you have to do, you have to create your IoT application and after you have created your IoT device. Here we can see a sample related to the charging station model that we have already created. So if you remember, we have created a charging station model, and here is a sample of one device connected to the charging station. So also in this case you have many kind of different data, so data related to IoT broker, general information comprising the relation with the model, the charging station model, and the values, the possible values that are related, are connected to the IoT device. And obviously the values are the same described into the model to which the device is connected. Once you have created the device or the devices, you can also send the dynamic data. How? You have to create an IoT application. So you already know where to find and when to create an application. So IoT app, create a new one, wait a moment, and then in this case we can see this sample, the charging station IoT application, that begin with a block that is the data ingestion block, the data injection, and is finalized to write to define the frequency of update of your data, when the flow will start, how often the frequency, every 5 minutes, every 50 minutes, and so on. And then you have to ingest the data. In the case of the charging station, we have an external service. The charging station are data coming from the open data server of the Comune di Firenze. The data are open data, so that we can explain this sample to you. The data are downloaded thanks to a query that is made on the server. We can make a set of transformation and create a message here, in order to create a message that is sent to the broker. With this action, we send the data to the broker. So we can go in details and see the single blocks, the main single blocks. So the inject block is the first one. Here you have to define simply the frequency of update, as we have already seen. Then we have an HTTP block. These are the names you can find into the your IoT application left side. So if you write inject, you will find the block something like this. So the HTTP is this one, and in this block you have to put the URL from which the data are coming. For example, in this case, the data comes from Comune di Firenze, so you can find the server or related to the Comune di Firenze. And you can also describe the method, so in get. Then we have a set of blocks that are here, that are necessary to convert the data and to parse the data and so on. So the data is coming in XML and have to be parsed to be compliant with the JSON format. So then we can use a function block in order to create the final message, the one that we have described before. And this is the function block, and if you can see that this is a JSON, and in the JSON message you have to be compliant. You have to create the JSON message in compliance with the charging station model, with the IoT. So if you have defined a set of values in the IoT, you have to send one value, one data connected to each value that you have defined into the model. So, for example, here you find the charging state, and also here we can find the charging state. So attributes name, attribute value. This sensor data stato ricarica is the real-time value, is the periodical value. And this for every value that you put into the device. And the final step is send the message you create, this one, to the fiber, to the Orion broker. So you have to use the fiber Orion block and to choose the Orion service. This service have to be the same you put into the model and into the device. As you know, one tab was related to the IoT broker. So in your device, you already have the name that you have to put into the fireware block, and also the key. The key, if you have a unique key for one devices, you can go to the IoT devices and search for them, or if you have realized the bulk upload is the key 1 and 2 that you put into the CSV file, and so on. Okay, so we have completed this part, and here you can find more information. So if you go to the slide, you can see that these are linked, and these are the arguments in order to that can be detailed more in some pages that are on the Snap4City platform. So here you can find these and other use cases and other general description related to the Snap4City platform. So another service is related to the data ingestion via API, so external services using HTTP microservices on IoT application. So what is a microservice? It's something that can be reusable from you or from other developers, and is connected to the REST call API. So each API can be automatically transformed into a microservice. The microservice can be then used directly in an IoT application. So you have to go to the resource manager, so the menu, resource manager, microservices for application, and here you can see the list of all the available microservices. If you are a tool admin, you can also create a new one, or you can also modify them. This is the pop-up that is visible if you can edit or create a microservice. Here you can see that you have to put some details on the description of the microservices. So the name, what the microservice is going to do, what is the name of the code. Now you are what will be the name of the code, and that is connected to this one, and you have to choose the nature and the subnature of the microservice that are connected, that should be connected to the CKAN4City ontology. You can establish the license that can be public or private of your microservices, that it is obviously connected to the data you are managing. And the data, I'm talking about the data because you have to put the API. So in this case is not related to the Snap4City services, but it could also be related to the Snap4City services. So a specific URL providing a set of data can be put here. So in this case is an external services related to the city of Antwerp, and so are the Antwerp camera location. And you can also add a description related to the microservice. Why you are going to do a microservice? Because it can be usable many times and in a fast way from your or from a general IoT application. So you can create a new IoT application, click on this button, so import external microservice, and choose one of the possible microservices that are available. For example, here we have chosen to install the Places in Finland microservice, and if we click on Install button, a new block on the left side of your IoT application will appear. now you can use the block into your IoT application. So putting it into your IoT application and click on it, defining the parameters in order to use it, to use the service. A more general solution can be used in order to bring data from a set of API to the dashboard. The simple modality is to create an IoT application exploiting the REST API, and in the IoT application you can send the data directly to the dashboard using a set of microservices. You can send data on some registered IoT brokers and also posting data automatically on the knowledge base and on Elasticsearch and so on. You can send data on a set of MyKPI using MyKPI microservices. You can also save or consolidate your REST API, transforming it into a microservice that can be also usable from you, but also from other colleagues if you describe and if you create the microservice as public, as we have already seen before. If your REST API is going to use credential and username and passwords also, we suggest you to save them into the My Personal Data of Snap4City, so that the code will not be provided every time, so the credential will not be provided in clear, and you can update from the user's interface on your personal profile, the credential from your personal profile, and the IoT application can retrieve username and password at the moment in which they are used with the security level high. An alternative solution can be using create and using the ETL approach, so a set of extracting, transforming and load processes to send data on HBase storage or on data shadow via some IoT brokers. So the ETL can send data on a registered IoT Orion broker, can send data to a set of MyKPI, can save data on HBase using Phoenix for long-term storage. So how regarding the data ingestion on the MyKPI via IoT applications? You have to create your KPI, so you have to go to My Data, KPI POI, and click on the Add My KPI button. So this is the view. The button is here. From this view, you can also see the list of the already available KPI, also the KPI you have created in advance. So we can also start this action with a sample related to the Lonato car park. In this case, we want to monitor a set of free slots into a car park. So we have created 3 KPIs: number of free slot, max duration of in terms of time for each slot in which each slot is free, and the related identifier. So for example, here we have the description related to the num free slots KPI. In this case, you can see the name here is one of the fields filled in. You have also to define the network and the subnetwork that are connected to the CKAN4City classes, that is the multiple ontology. Then you have to define the type of the the KPI, the value unit, and the data type. So this is a slot and is an integer in terms of data type. And then you have to add also the location, so latitude and longitude. So in order to send the data to the KPI, you have to create your IoT application. So go in IoT application, create a new one. Here we can see the main blocks in order to realize this action. So to send the data to your KPI. So you have to create the application. We call it Smart Parking Clonato del Garda. That is the name you can see here. And the first block is the injector. So the first one in which you have to choose to select the frequency of update. Usually is in terms of seconds. So how many seconds, minutes do you want to repeat the flow? You want to read your data, and you have to specify this in the inject block. Then you have to use the HTTP block, because in this case we have an external server from which we take the data and get, and so we will put in this block the API from which we take the data. And then you have to create a use the function block in order to convert the data you are uploading in a specific format, that is a JSON, and this JSON is capable to send the data to each KPI. Here is the one sample of the JSON that has to be sent to each KPI. So here you have a JSON message for each of these connection, and this message have to be sent where? Into your KPI. So you can use another block that is save MyKPI data values, from which you can choose the KPI to which you want to send the data. And here you can see that you have founded the num free slots KPI that you have already created. So this is completed, and the flow is finalized now.